Hello friends, welcome to the new video of my channel. Today we are going to learn about congruent modulo. Two integers are congruent modulo n if they have the same remainder when divided by n. This is written as a congruent b mod n, which is eventually a equals to b plus nk. Now note a congruent b mod n, which is equivalent to b congruent a mod n. It is because numbers within the same group are considered congruent modulo the division. For example, numbers like 1, 7, 13 and 19 all belong to the same group when divided by 6 because they all have the same remainder of 1. Now, there are some key points to remember regarding congruent modulo. Congruence is a fundamental concept in modular arithmetic, a system of arithmetic where numbers wrap around when they exceed a certain value, right? It's an equivalence relation, meaning it's reflexive, symmetric and transitive. It's also related to divisibility. Two numbers are congruent modulo n if their difference is divisible by n. And the core concept is the same, remainder when divided by the modulus n. As you can see in the example, 51 congruent 1 mod 5. Then 51 minus 1 is divisible by 5, which is the same as the core concept is the same remainder when divided by modulus n. If we divide 51 by 5, the remainder will always be 1. Now we are going to learn about a possible problem which is very common in exams. Okay. So the question here says x congruent 1 mod 3. Then what will be the value of x? First, write it in equivalence relation x minus 1 by 3 equal to k let. Now we put values of x in the equivalence relation to find whether it is divisible by 3 or not. So here we see at x equal to 1, value of k equal to 0. That means at x equals to 1, it is divisible by 3. But at x equals to 2 and 3, it is not divisible by 3. At x equals to 4, it is again divisible by 3. At x equals to 5, 6, it is again not divisible by 3. Again at x equals to 7, it is divisible by 3 and so on. We are getting x equals to 10 as divisible by 3 as well. Now there will be infinitely many numbers that are divisible by 3 if we go on continuing in this way. So that is not a way out. Then what is the catch to find out the value of x? The catch is, always remember, there will be at least one solution which is less than n. Now what is n? As in the definition, I have written this is n. And what is n in the given question? It's 3, which is the modulus number. So here n equals to 3, the value of x should be something which is less than x always. And in the given question we are getting at x equals to 1, it is divisible by 3. That is, we are getting value of k equals to 0, which is a whole number. That means it is divisible by 3. So for us, the answer will be x equal to 1. Clear? Now there are some more examples relating to this. What if we get 2 equivalence relations or 3 equivalence relations? Now we are going to learn about that. Here I have taken a problem with 2 equivalence relations and we are going to solve the value of x. How to do that? First we individually find the value of x for each equivalence relation. That is for x congruent 1 mod 3, we find the values of x for which it will be divisible by 3, and for x congruent to mod 4 we find the values of x which will be divisible by 4. Now it is a very important concept. When there are two relations, we have to multiply two n's. Which are the two n's? This is n1 and this is n2, which I have written here. We have to do their product, and the common solution in n1 and n2, which has to be less than the product, will be the solution of x. Here, as you can see, at x equal to 10, in both n1 and n2, we are getting a common solution. So the answer will be 10, right? Now let's move on to the next problem, which is in relation with three equivalence relations. Friends, I think we should stop for today, because the next problem with three equivalence relations, we need to learn a new theorem, which is Chinese remainder theorem, and that will take some time. And I don't want the video to be monotonous and boring, so I'll just make it crisp and short. I will cover the problem in a later video, which will publish soon after this. So till then, enjoy mathematics, and I'll catch you guys up in the next one. Cheers.